Bismillahirrahmanirrahim and Assalamualaikum warahmatullahi wabarakatuh. So today, we will be presenting our industrial visit experience to Nitto Denko Material Malaysia Sdn Bhd, which took place on 17 December 2025. This visit gave us valuable exposure to real industrial practices, especially in advanced material manufacturing, quality control, and industrial operations. Throughout this presentation, we will share the overview of this company, what we observed during the visit, key technologies and processes, and the most important part, the finding and lesson we learned as an engineering students. We hope this presentation gives both useful insight and a clear picture of how engineering concepts are applied in real industry. Okay, so before we start our presentation, let me introduce our group members. First, we have me, Akmal Arif. Then we have Adham Aziz, Ayman Shazwan, Alif Hakimi, and Ahmad Hassan. Okay, so firstly, we look into the background of the company. Okay, so the company we choose for our site visit is Nitto Denko Materials Malaysia Sdn Bhd. Okay, so the company is located in Section 23 Shah Alam, Selangor, and was established on 18 February 1993, with business operation officially starting on 1 April 1994. Nitto Denko specialized in the design, development, and manufacturing of adhesive tape, which are widely used in industrial and electronic device and components. This product play a critical role in precision manufacturing, insulation, protection, and also bonding processes. The company has paid up capital of 55 million ringgit and employ 284 workers as of month of November 2025, indicating a medium to large scale manufacturing operation. In terms of physical scale, the factory occupies a land area of 30,036 square meters, supporting large-scale production activities. From an OSH and quality perspective, the company is certified with ISO 14001 for operation environmental management, ISO 9001 for quality management, and also ISO 45001 for occupational safety and health, demonstrating strong commitment to safety, quality, and also sustainability. Okay, next I will explain about the company branch. In Malaysia, the company operates two sales offices, one in Selangor, located at Menara High Tech Village in Subang Jaya, and another one in Penang, located at E-Gate Gelogo. These sales offices support customer engagement, technical consultation, and also order management. The main manufacturing factory is located in Section 23 Shah Alam, which is strategically positioned near major highways and industrial zones, allowing efficient logistics and distribution. The map highlights the strategic location of Selangor and Penang, which are key industrial hubs in Malaysia, ensuring nationwide market coverage. Globally, Nitto has 99 branches worldwide, with strong presence in East Asia, Japan, South Asia, Americas, and Europe. This global network allows technology sharing, standardized manufacturing practices, and consistent safety and quality standard across all operations. Okay, next for the company philosophy, Nitto emphasizes safety as their top priority, placing employee well-being before productivity. This aligns strongly with OSH principle in manufacturing environments. The philosophy also highlights sustainability, encouraging harmony with society and the environment, alongside respect for diversity and human rights. Nitto also promotes innovation through session activities which focus on continuous improvement, creativity, and proactive problem solving. The concept of niche top reflects the company's strategy to lead specialized market rather than compete on volume alone. The corporate pyramid summarizes this philosophy. The mission is to contribute to customer value creation through innovative ideas. The vision is creating wonders by developing advanced materials and solutions. All of this driven by the Nitto way, which emphasizes teamwork, speed, responsibility, and continuous personal development. Overall, this philosophy ensures that innovation, safety, and customer value grow together in a sustainable manner.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Shazwan bin Muhammad Fatia, and now I'm going to be talking about the production section. Itu dokumentasi sedang berehat. The productions is divided by two parts, which is the NMM2 and also NMM1. In NMM2, we have the PD0, PD1, and also PD4. PD0 is responsible for glue manufacturing, which is the base material of the tape. PD1 performs the coating process, where adhesive is applied onto the baking material. PD4, where the rewinding and cutting process happen into the final roll sizes, which is the jumbo roll. And at MM1, we have PD2, PD3, PD4, and also PD5. PD2 is where the handle of slitting of large rolls into the narrower width, which is the finishing before the packaging process. And PD3 is where the rewinding process happens. PD4 is also the same as NM1, where the rewinding and cutting into the final roll sizes. PD5 is where the setting process carries out with precision and also pre-cut processing in clean room conditions for high technology electronic products. Now moving on to the flow layout. Before we understand the production process, we first must know the flow layout of these buildings here at Nitto Denko Materials. So the first building, which is the NM1, it consists of PD4, PD5, PD2, and also PD3. The first floor, which where the PD4 happened. The second floor is PD3, PD2, PD5. And at the second building, the the PD4 happened at the first floor, while the PD3, which is the new production department, happened at the lobby, at the ground floor. Now this building has two buildings for NM2. It is connected through a small tunnel which connects to the back of the building, and we can see it from this floor layout, which is where the PD0 happened. We have the ground floor, the first floor, the second floor, and also the third floor, where most of the PD0 happened. And now we will be talking about the production process flow. So for PD0, it is responsible for glue manufacturing, which is the base product for all adhesive tapes. In this department, raw chemicals undergo polymerization and the formulation to produce emulsion-based adhesive. Additives are blended to control properties such as tack, viscosity, cohesion strength, and temperature resistance. Since adhesive performance determines how well the tape works, PD0 plays a very fundamental role in product quality and performance. Moving on to the PD1. PD1 performs the coating processes. With the adhesive produced in PD0 is applied onto base materials such as paper, washi, or film using a continuous coating line. The coated material then passes through a temperature-controlled oven to dry and cure the adhesive layer. Forming jumbo-coated rolls, PD1 uses precision thickness control and wet tension control, and drying technologies to ensure uniform coating and persistent performance. PD2 handles the slitting process. Jumbo-coated rolls are slit into narrow rolls based on product width specifications. Precision slit dimensions ensure the accurate dimensions and clean edges. This stage is very important because the width accuracy directly affects the usability and performance of the tape in the industrial and electronic applications. Up next, the PD4, which is responsible for rewinding. Cutting operations, rolls are rewound to specified lengths according to customer requirements, and log rolls are cut into final widths. This ensures the finished product meets dimensional and packaging specifications. PD4 ensures proper roll structure, consistent length, and also the readiness for customer use. Last but not least, for the production process flow, the PD5. PD5 performs precision slitting and pre-cut processing under clean room conditions, typically class 10K. This prevents dust contamination, which is critical for semiconductor-related products, such as resin tips and electronic component tips. PD5 represents high technology manufacturing, where cleanliness and dimensional precision are very much essential. And now we will be talking about the design concept and the quality assurance. So now, um, different washi tapes are designed for different purposes, and their adhesive properties and backing materials are adjusted accordingly. For example, the purple washi tape is designed for construction, painting, providing strong adhesion with clean removal. Next up, the yellow washi tape is for general purpose, offering balanced adhesion and also the flexibility. Moving on to the next, the cyan washi tape is used for sealing applications, ensuring reliable bonding. Next up, the orange washi tape is designed for vehicle finishing, where the surface protection and paint compatibility are critical. Lastly, the maroon washi tape is made for heat-resistant insulation, which is able to withstand the high temperature. These differences show that the product design is based on an end-use performance. Quality assurance ensures each step meets required specifications through control production and also the lab testing. Thank you so much. That is all from me.
Assalamualaikum. Nama saya Najib and I'm presenting about the product spec or the problem faced for this company, which is different. First, the adhesion failure, which is this occurs when the tape fails to adhere properly to the surface it's intended to bond to. This can be due to improper surface preparation, unsuitable adhesive, or the wrong type tape for the application. For example, you cannot use a standard tape for a painted wall since it can be easily tear off. Next is the cohesion failure. This involves to the tape itself failing to hold together either within the adhesive layer or between the carrier and the adhesive. For example, is that when you use a tape for a heated spaces, if the tape is not suitable for the heated place, then it will easily tear off. Next is the vacuum failure. This can happen when the tape is used in environments with excessive vacuum leading to the tape peeling away from the surface. For example, is that the tape used if you use a tape on a place that has no pressure or air, then the tape can easily be peel off since there's no pressure forcing the tape to stay on the surface. Next, I will be presenting the root causes of adhesion failure. Firstly is the environmental condition. Exposure to extreme temperature, humidity, or UV radiation. For example, is that put when you place a tape in front of your house or outside, it may be exposed to extreme humidity or UV radiation a lot, and then because of that, in a few hours or days, the tape can be easily peeled off. Next is the improper application techniques. Adequate pressure or alignment during application. Okay, when you place a tape on a surface, you have to push it really hard so that the tape stays on the surface. But if you don't put enough pressure on the tape, then the tape will not stay on the surface. After that, the material incompatibility. Tape adhesive chemistry not matching the substrate material. Next is the incorrect tape selection using tape not suitable for the surface energy or application condition. For instance, that when you use a duct tape on a paper compared to a cellophane tape on the paper. Both are tapes, but if you use a duct tape on the paper, then the duct tape stays a lot longer than the cellophane tape. After that is the incorrect tape selection. Presence of dust, oil, or moisture on bonding surfaces. If you peel a tape from the tape, then when you put your hands on the tape and you try to stick it on the wall or on the surface, it will not be as sticky. It will not be as stickier compared to before you touch the tape, since there's dust on your hand which stays on the tape. After that, the impact of manufacturing and operation. So the firstly, product reject rate increases, the reduced product lifespan, the increased maintenance cost, and the customization and the customer dissatisfaction. After that, the safety hazard. Because of that, the it will cause a lot of effect on the manufacturing and the operations by Nitto Denko. That is all for me. Thank you.
The industrial visit to Nitto Denko, Malaysia, Sendirian Berhad provided valuable exposure to real industrial practices, particularly in manufacturing processes and occupational safety and health (OSH). Through this visit, students were able to connect theoretical knowledge learned in class with real-life industrial applications. One of the key aspects observed was the company's strong emphasis on corporate philosophy and quality-oriented production. Nitto Denko follows the Nitto way, which focuses on innovation, customer satisfaction, and continuous improvement. This philosophy is clearly reflected in their systematic production process and strict operational standards. The production process flow demonstrated how raw materials are handled in controlled environment, especially in clean room condition. Processes such as slitting, pre-cut fabrication, and packaging are carefully managed to ensure product quality and consistency. This highlights the importance of precision and contamination control in manufacturing adhesive and electronic material. In terms of occupational safety and health, OSH, the company places high priority on employee safety. Safety briefings, personnel protective equipment (PPE), safety signage, and adherence to standard operational procedure (SOPs) were clearly implemented throughout the facility. These practices help reduce workplace hazards and create a safer working environment. Overall, this industrial visit enhanced students' understanding of manufacturing technology, quality control, and OSH implementation. It also increased awareness of professional responsibilities and safety culture in industrial settings, which are essential for future engineers and technologies.
Assalamualaikum warahmatullahi wabarakatuh, and good morning everyone. My name is Ahmad Hassan Ijlal and my student ID is 2023435852. Today I will be discussing continuous quality improvement or CQI, specifically within the context of Nitto Denko Corporation. As a global leader in material science, producing everything from the polarizing film in your smartphone to medical transdermal patches, quality is not just a goal for Nitto Denko, it is their survival mechanism. Before we dive into Nitto, what is CQI? Unlike traditional quality control, which acts like a policeman catching mistake at the end of the line, CQI is a proactive philosophy. It follows the PDCA cycle, which is plan, do, check, and act. It assumes that every process can be made better, more efficient, and more sustained. At Nitto Denko, this means moving from zero defects to predictive excellence. Now, let's move to the CQI for Nitto Denko. First, we must embrace smart CQI. Nitto operate on a massive scale with roll-to-roll manufacturing. In this environment, if a defect is only detected after a roll is finished, the financial loss is already incurred. My proposal is to integrate IoT sensors and AI to monitor the film thickness and adhesive properties in real time. This shifts our CQI philosophy from detecting errors to predicting quality. By identifying the deviation before they became defect, we eliminate waste before it even happened. Second is the optimizing of our yield rate using Six Sigma methodologies. For high precision products like optical films, even a micron-sized dust particle can lead to total reject. By empowering the DMAIC cycle, define, measure, analyze, improve, and control, we can systematically or reduce the variation within our clean rooms. The goal here is a deep dive root cause analysis to ensure that expensive raw material are converted into sellable product at the highest possible rate. Third, we need to bridge the gap between R&D and production through cross-function CQI. It is common for brilliant R&D concept to face stability issues during mass production. By implementing design for manufacturing, which is DFM, we ensure that feedback from the factory floor, the gambar, is integrated directly into the product design phase. When we design with the operator reality in mind, we achieve stable quality much faster in the product lifecycle. Fourth, we must evolve toward green CQI. Today, quality is no longer just about physical performance. It is about environmental impact. We should incorporate carbon reduction and energy efficiency into our core quality KPIs. For example, our CQI cycle can focus on reducing the use of chemical solvent in adhesive production without compromising bond strength. This ensures that Nitto quality standards align with the global sustainability expectation. Next, we must strengthen the Kaizen culture at the local level. CQI should not just be a top-down directive from HQ in Japan. We need to revitalize quality control circle QCC in our international plans, such as those here in Indonesia. By empowering and recognizing small, bottom improvement suggested by frontline operators, we foster a culture ownership. These small daily wins eventually lead to the massive gains in global operational efficiencies. Finally, feedback currently often left in sales report, isolated from the production line. My proposal is to create a direct digital pipeline where customer complaints or performance data from the field are fed back immediately into our CQI cycle. If a smartphone manufacturer finds that our film is likely too rigid for their new curve screen, that voice of the customer should automatically trigger a process review by closing the loop between the user and the factory. We ensure that our improvements are solving real-world problems, not just theoretical ones.